So this means we don't need any more mathematicians and physicists in our world. So no more Ramanujams and no more Einsteins in this world.
The point is there is nothing so mind-blowing that we are going to achieve if AI is already going to do everything for us in this century.
That's true. Hello all. Welcome to another episode of Chaotic Chintan, an attempt to understand the chaos around us. Today we are going to talk about, my name is Pankaj Kumar and I have Vaidehi with me.
Hello.
Today we are going to talk about LLMs, AI, and how that can be used in research. And primarily we'll focus on LLMs and similar models. We are not going to talk much about the traditional machine learning models because, traditional machine learning models, so just for our audience, large language models are machine learning models. The only difference is the traditional machine learning models do one thing specifically and they do it really well. So for instance, if you have a model for classification, it will classify really well. And usually when you classify a data set, you train it to classify a certain type of data set. You cannot take a model that is trained to classify X data set to classify Y data set. So it has to be in the similar region. Whereas language models, because they are language models, they tend to inherit a lot of language properties. So we are going to talk about LLMs and the related models and see how they can be used in research. So let's start with understanding what can today's AI do? Like what are its capabilities? Again, when I say AI, I'm mostly talking about LLM. So when we say it can do something, or let's say it can do research, before we go into the details of that, we need to understand what is it, the core capabilities of our AI models.
Right. So, well, since you mentioned LLMs, and that's what we see as AI today. So, as the name suggests, LLMs are large language models, so they can summarize text very well. And if we give it complex, large documents, scientific, mathematical, or any subject under the sun, it would be able to summarize it and give us an accurate summary. And then there are what are classified as large action models. I think some people are throwing around that term, although it's not really a separate category. But the point is that there are models that can perform specific actions as long as they are properly prompted to do so. So that is the three core functions. But the extension of the fact that language models interpret language the way we humans do is that they can nearly reason because they are generic enough to understand a language, and when I say understand, to be able to take in your inputs and respond accordingly using all of the predictive functioning, that if you asked a model today a logical question, it would give you a well-reasoned answer. So they can almost reason. Emphasis on the almost.
Yeah. Okay. So my understanding is language models, they are trained on large set of data, mostly free text. But that I understand, it tries to predict the next word and makes sense, right? Like you have trained it on words, so it can predict the next word. But when you say it can reason, what do you mean by that? Because we are not training it to reason, we are training it to predict next word.
Yeah.
What do you mean when you say that it can almost reason?
Yeah. So that's right. We're basically training it to predict the next most natural text or speech to say. But when we say it almost reason, and it's not something that we're just saying, it's actually been tested, and there are metrics that are applied across all LLMs available today to prove that. So it is the metric that is used to assess reasoning is called ARC metric, and the most famous of our LLMs, ChatGPT, has been measured to have a metric of about 7% ARC rating, whereas a average adult human being would have an 80% ARC rating. So obviously these LLMs aren't functioning and reasoning at a adult human level,
Yeah.
but they are showing that property. Now, how is this measured is obviously based on giving logical inputs instead of a specific set of pre-trained inputs or just asking it to predict certain text. There are very specific experiments which have been done, which you can find in the links. But essentially the point is that they are able to give logical answers. Now, why are they able to give logical answers, or why are we even as humans being able to give logical answers? It's a function of language, really. The fact that when they are able to predict the right text, the next emergent property from that language prediction is reasoning.
What you're saying is, because we are training the models on logical texts, it is inheriting that capability. So if I put it differently, let's say if I take a book of lies, or if I train it on 3 books of truth and 7 books of lies,
Yep.
and the only thing that exists in those 7 books is a lie, and if we train the model on that, logical reasoning may not be a property. It may not be a property that emerges out of this.
And it is the same way. For example, anybody who has kids will know that the environment or the information they expose their kids to is what results in certain behavioral aspects.
Sure.
So it is pretty much the same way that you would train a human being,
Yeah.
a little person. Depending upon what you train a model with. Now, obviously, the content out there on the internet and misinformation is a big problem today. There is a lot of misinformation.
Yeah.
But based on all of the information sources that are available, because it has been and to put it very simply, it's not been trained on a specific set of logical inputs. Like, for example, if you remember your childhood days where you had to take, let's say, a quants or a competitive exam, you would train yourself on those aspects. That's not what is being done with an LLM.
Sure.
It's been trained on all the information out there. But why does it look like it can reason? Is because it's been trained on all the available factual information and everything else on the internet, and it is able to decipher what would be the next logical thing to respond to a certain question,
Sure.
because that's a natural response in the language.
Correct. So the reasoning is sort of built into our language, and that's the reason why the model
Yes.
tends to be logical. But also, I think it is not trained on social media yet.
Yeah.
So, well, Grok AI is, but most of the other models are not trained on social media data. So they are usually there is I believe there is a set of data set that is
Yeah.
shared. Okay, so OpenAI uses their own set of data sets, which
Yes.
is most of the internet. But the open source community itself, they have a predefined set that they train their models on. So not all models are trained on everything. Open source models are trained on very specific data sets, so Wikipedia or things that are available to everyone. So, and those documents tend to be more truthy than non-truthy. So that's the reason I believe is
Yeah.
why it seems to be showing logical reasoning properties.
Yeah.
And for our audience, when we say ARC is a benchmark used for measuring. There are other benchmarks, but ARC is the benchmark used for measuring reasoning capability. I think it's called abstraction and reasoning corpus. So
Yeah,
that's the set of
that's
tests that are used to benchmark reasoning capability.
Right.
Okay, so we are talking about reasoning being an emergent property of language, or LLMs showing emergence. But what exactly is emergence? Like, what exactly is emergence or emergent property?
So basically, if let's say an emergent property is something that occurs as a result of certain patterns or behaviors in that system. So it is not an inherent property of the system itself.
Yeah.
For example, solid substances, they stay solid because they have certain inherent molecular bonds. They therefore have certain properties of plasticity, elasticity, etc. But if an object becomes hot or cold, that is not an inherent property of the object. Temperature or heat
Yeah.
is an emergent property. So
Sure. So what you're saying is if we zoom into a molecule, or electron or an atom,
yes.
in itself it does not have a temperature.
Yes. So you cannot find that on the molecular level.
Yes. Yes.
Similarly, color, for example, is an emergent property. Individual atoms of an object by themselves don't have a color. It is because of certain radiations emitted and the way that light is reflected. It's very complex. I'm not going to oversimplify that for the purpose of this conversation, but essentially, properties that aren't inherent to an object are emergent properties. For a language model, its inherent property is to understand the language itself and say the most obvious thing in response to either an incomplete statement or a question. But because our reasoning abilities are built based on our language, we learn things verbally. That is the first form of learning growing up. You learn things based on verbal cues.
Yeah.
Therefore, reasoning becomes an emergent property of large language models as well.
Okay. So emergent properties. So I understand heat and light, but when it comes to, so language in itself is a quite abstract idea.
Yeah.
I mean, when I say abstract idea, it's an abstract thing, and from that we are seeing reasoning coming out of it when we train a model with a lot of. Okay, so are we expecting other properties also to emerge out of this? Because I mean, reasoning, although it's not perfect, but some of the model seems to reason
quite well.
Yeah, it's at par with a 5-year-old kid or 7-year-old young kid. Are there other emergent properties that we should be looking at?
There definitely could be, and it would be sort of an extension of reasoning itself, in the sense that you eventually these models should be able to behave like a general intelligence, what we call as AGI, artificial general intelligence. So that is the most interesting emergent property that everyone is currently talking about.
Yes.
And it would be exciting to see it when it actually happened.
Yes. So AGI would be artificial general intelligence, which is where we are expecting the models to behave almost at the level of an average person.
Yes, an average adult.
Yeah. Okay. So and we are expecting that to happen soon.
Yep.
A lot of people are working towards that, I hope.
Fingers crossed.
Yes. Okay. So all of this sounds very interesting, but how can we really use these this AI, this models, and all of these things to, like, how can we use it for ourselves? How can we use it for research, for instance? How will we do that?
Okay. So for that, we have to take certain real-life examples of what LLMs can do today and then go from there to what we can do in the future. So even before LLMs and the current form of AI burst onto the scene, we've had for several years chatbots in most of the large organizations. And essentially, what does it do? When you go to customer support, instead of talking to a human being, you actually have a bot that is responding to your questions. So it is basically another model. Obviously not as large or as versatile as an LLM, but it is a model that has been trained on a very specific set of inputs, and it can do natural language processing, and it can give you a response pertinent only to that use case. And this is not new. Neither natural language processing nor chatbots are new. They've been around for years now. And in those cases, the only functionality of the bot is to receive your questions and then tell you a response in text to that question. It does not actually do anything beyond that.
Sure.
Now the next level, now that we have LLMs which are generic enough to process all kinds of inputs, the next thing that is available to us is something called an AI agent, which is a wrapper on top of an LLM. So in addition to giving you a response about what to do in this situation, it can actually execute the task and take the task to completion. So obviously tasks online. We are not yet in the situation where we have enough IoT and robotics to execute physical tasks. That still requires human intervention. But the point is, if you wanted it to go somewhere and make an appointment, or if you wanted to add something to your calendar, specific tasks, we already have that AI agents for that.
Yep.
In fact, we have generic AI agents that people are offering up as virtual assistants to you. So there is something called ChatDev. And then there is something called AutoGen.
Yep.
So ChatDev, what it does is that it allows you to use their interface to create certain roles and develop a software by yourself using that. So essentially, you will have somebody who will write down what the requirements are. You'll have somebody to tell you what the solution is. And when I say somebody, I mean a bot in that software. And then you will have somebody to actually code it and then validate and test it. And it will keep reviewing until you ask it to, or however you set it up to do. So essentially, you already have things like that.
Yep.
Now, why are we talking about this? Because we are trying to explore how these are going to be useful in the field of research. And that is essentially what it is. In research, people would identify a problem area or some new thing that they want to find. And then they would define that very, very clearly. And then they would try to come up with a specific list of actions that need to be done. Just as you would do your day job, a researcher is a human being who has a specific list of tasks and needs to do it. And you could set that up in an agent model like this, and it would execute the task for you.
Yes. Okay. So to summarize what you're saying, so chatbots have been around for some time. That makes sense. Then the LLMs come into the picture, and chatbots suddenly become super useful because now they can do a lot more than just answer questions specific to that domain. So previously chatbots were rudimentary. They would answer questions based on a document, but they have to have that question and that answer stored. So they used to detect intent, and based on the intent, it will go into a specific flow, and those used to exist. Then LLM came and they gave superpower to these chatbots. So now these chatbots can answer any type of question. Not always accurate all the time. They do hallucinate. LLMs do hallucinate, and that's why the chatbot seems to hallucinate. And this is where ChatGPT, Bard comes into picture. They are traditional chatbots powered by LLMs, so that's why they look very powerful. But behind the scene, it is actually just a model which is trying to predict the next word. So that's all it is happening, right? Then you're talking about AI agents, which is another wrapper on top of an LLM, where it can give an input to LLM and gets an output from LLM, and based on the output from LLM, it will be able to take an action in real world. Real world in this sense is a virtual machine running somewhere, not we don't have, as you said, we don't have IoTs and things that are integrated with it yet. Although many IoT companies are now saying that their products have AI built into it, but they're mostly talking about machine learning models, not necessarily LLMs, right? I noticed you mentioned ChatDev. So ChatDev, as you said, is a group of agents that does things. So that's one of the things that seems to be, if it does it well, can replace a lot of developers and testers and business analysts, because ChatDev by design it's an open source project, I believe. So that means you can just go now and download it and run it on your system. So as long as you have OpenAI API or your own model running in your local machine. Microsoft, I heard, has a similar product. They are calling it AutoGen, and that is also open sourced. So you can do that as well, although the user interface is a little different and it's targeted for enterprises. So a bit boring, but try it out. It's open source. So so agents can be given a task and they will try to complete it independently, and they can also be set to verify the results themselves. So that way we don't have to do a lot of
Yes.
work. And you're saying that this model will work for research as well. Because I see a lot of developers using this to develop small applications, not so much a complex application, but simple games and things like that, but not big things. So
Yeah, I mean, the idea is that in research, there's a lot of investigation required, a lot of investigation of data, trying to correlate patterns. And this will sound very generic, and it is applicable to all fields of research, that you go through a large amount of data, you try to correlate things, and then you try to derive some patterns or meaning out of it. Over the years, rudimentary machine learning models have helped a lot in this field already.
yeah,
But we are talking about an AI that, instead of just looking at specific structured data and having to develop a new model each time that can cater to a particular subject or a use case, we are talking about more generic AI which can assist in every field of research with these kind of steps, sorting through information and testing hypotheses and things like that.
yeah. Okay. Okay. Let's take a specific scenario and run with it. Let's take mathematics and see how an AI agent will be able to help with research in mathematics. So what are the possibilities?
Okay. So in the field of mathematics, and as any student of mathematics would understand, broadly there are 9 or 10 axioms that govern mathematics.
Okay.
So when we say 9 or 10 axioms, axiom essentially means a very obvious and self-evident truth. There are 9 or 10 such rules that essentially subsume all of mathematics under them, and that's where everything originates. Now, based on these, mathematicians have been developing theories over time, and theoretically, you can have an infinite combination of theories for any branch of mathematics.
Yeah.
But we have had tens of thousands of them created over time, out of which 1,000 or so are proven, and we have around 1,200, as Wikipedia says, which are documented on their open source page. So essentially, these are hypotheses that say that if you have a specific set of conditions, then this is the mathematical outcome that you will get. And there are infinite possibilities for that.
Yeah.
Now, over the years, we've had many researchers either come up with logical ways, they come up with their own math and then they conclude with the final theorem, or we've had some very brilliant minds that have just come up with theorems and over time they have been able to prove it.
Yeah.
Or some have not even been able to prove it, and then later, over the centuries, people have proven them to be true. Example of an Indian mathematician who had a lot of theories was Srinivasa Ramanujam, where some of his theories could not even be proved in his lifetime, either by him or his fellow mathematicians, and were only proven by further generations. But the fact is that he did come up with a lot of theories. Now, it took hundreds of mathematicians over several generations to come up with a few thousand theories, and where there are infinite possibilities.
Yes.
And these are all hypotheses, permutation combinations of various scenarios, to put it very simply.
Yeah.
So a model that can sift through the list of rules that are available, which understands the basic 9 or 10 axioms, and then also has the theories that we know today available to it, will then be able to provide more and more theories in rapid response time. So what we could do is we could utilize these models to first, and this is probably an eventuality that someone will develop a model to come up with a whole load of theories that would take us generations to do. And once you have, let's say that you do have a sample theory, now what would you do with that? You would develop an agent to be able to then evaluate that theory and prove it. So now, either that theory will get proven or disproven. But the point is, you can go through those thousands of theories using a model and you can get all of the mathematical proofs that are available. So what takes years and months of starting from basic arithmetic to very complex math for a human being to do
Yeah.
will be really speeded up by these models.
So what you are suggesting? So I think this is sort of related to what Gödel was talking about in his incompleteness theorem, where in um in a mathematical system, you can either either know all the theorems that exist, or you can know that the theorems that you have can be proven 100%. Will give the link to the theorem itself, in completeness theorem. Obviously I don't remember it off my head, but that does talk about identifying all the possible theorems that exist in a mathematical system. Now what we are talking about is having AI agents coming up with these theorems and then trying to prove or disprove these theorems, by which, if we are able to successfully prove and not disprove a theorem, that would mean like all the work that we are doing, like all the mathematical research and work that we are doing now, kind of is automated. Like
Yes.
it will be done by a AI agent sitting somewhere. Like it's not sitting anywhere, but it will run 24 hours
in the cloud.
trying to run mathematical. I mean, it will do reasoning and then come up with derivation for its hypothesis, and we will be able to create a database of all the possible theorems that have been proven, and it'll be a wonderful world, because it should open up a lot of new avenues for us to do research on. I mean, because in mathematics there are very interesting problems that are not solved. For instance, P problem, things that we don't know. So there are few types of problems. There are problems that we know we can solve, and we know that it is going to take a lot of time to solve. Then there are problems that we don't know if we can ever solve or not, and the amount of effort required to see if we can know whether we can solve it or not is sometimes equal to the amount of effort required to solve the problem.
Yes.
So, and it happens in
Yes.
in computer science
Yes.
as well. And with these models, we will be able to bridge the gap of some of these theorems, and we will be able to get to
And
knowing a lot more.
while all of this sounds very theoretical, it does have an impact to a lot of day-to-day things that we don't realize. Most of technology develops because the pure science behind that has been figured out.
Sure.
So, yes, while all of this coming up with mathematical theories, solving them feels very theoretical to us, the point is that only when we cross this bridge will we then be able to imagine all of the possibilities that can come out of that. Apply it in the world of physics, chemistry, biology, wherever required to solve whatever constraints that researchers might be working with today.
Yeah. I wonder what will happen to the cryptography and the security of the world, but we'll see. We'll see how we go with the research. Okay. So this means we don't need any more mathematicians and physicists in our world.
Well, the way if you start extrapolating all of the purposes you can use these AI for, then I don't think any of us will have anything to do.
Yeah.
And we can all sit back and say, it's a wonderful world, I'm having everything done for me. And hopefully we will be able to sit back and do that with a universal basic income. But let's not go down that
Yes.
path now.
Okay. So no more Ramanujams and no more Einsteins in this world.
Afraid not. Looks like we've seen the last of Srinivasa Ramanujam and Albert Einstein.
Interesting.
Such legendary people belong in the previous century.
Let's see how AI gets there.
Our century is the century of AI.
Yes. Probably the decade of AI. I think after a point we'll just be so used to it that it feels.
The point is there is nothing so mind-blowing that we are going to achieve if AI is already going to do everything for us in this century.
That's true. Yeah, that's true. On that positive note, thanks, Vaidehi.
Thank you.
Thanks everyone for listening to us, and please don't forget to like, subscribe, and click all the other buttons around, except for the dislike button. Thank you, and see you in the next episode of Chaotic Chintan.